Whenever we have someone on Earth, let's call that someone an Earthling, they're going to experience this gravitational force. But then we also said that any two masses are going to exert a force on each other that's given by, let me go back a few screens, by this expression. Now, what if we apply that force to people on Earth? I mean, we apply that expression to the Earth and the people on Earth. Can we find the gravitational force that the Earth exerts on Earthlings by using that same expression? Okay, I'll go back to this slide. But I'll skip here for a second. So this is what we are talking about. Can we think of every object on the Earth as a mass, and the Earth as a mass, the blue big mass? What force are they going to exert on each other? Now, what we are saying, F is G M blue M red over D squared. If it is a universal gravitational law, we should be able to apply it here as well. Now, so if we are going to apply it, consider the sizes. And blue is going to be the mass of the Earth. M red is going to be the mass of whoever is on top of the Earth, mass of Earthling. Now, what about the separation between the Earth and that Earthling? You usually measure distances from center to center. So that's the average separation. For example, this end of the Earth is much farther away than this end of the Earth, but the average position of the Earth is at the center. So we measure from center to center. Now notice, here it's a small diagram. In real life, it's even more prominent. This is very tiny compared to this, which means this D here is not really much different than the radius of the Earth. Okay. Now, if we apply that, this is what we have then. The force that the Earth exerts on an Earthling is going to be G, the mass of the Earth, the mass of the Earthling, the distance separating them squared. And the distance separating them squared is the radius of the Earth squared. So this is what we get. But since it's the same gravitational force as the gravitational force we talk about here, that force should be equal to this. And what's this? What's this M? It's the mass of the Earthling. So what we are going to do is, in this equation here, we try to isolate this a little bit, kind of to move it around. So it's just the same expression. See, we have everything. I just moved M Earthling out of the ratio. Once we do that, what do we notice? We notice that this equation can look like this thing times M Earthling. This thing times M Earthling. What's that thing? It reminds us of M times G, or G times M. Which is exactly what we have. G Earth times the mass of the Earth. What does this say? gives us an expression for G at the surface of the Earth, what I have on this circle. Okay. So what this gives us is G at the surface of the planet. It is big G, mass of the planet, radius of the planet squared.